Transportation is the backbone of modern society. Because of modern transportation, we have higher access to employment, education, trade, and social connection. Every day, millions around the world rely on different forms of transportation to get where they need to go. Transportation is routine, but it is not without risk. To better understand those risks, we will evaluate data gathered by the U.S. Department of Transportation on every public transit safety event from 2014 to 2024. We are going to look at when travel becomes dangerous, why it becomes dangerous, and what changes we can make to improve transit safety. This first chart looks at the average number of fatalities per incident on three modes of transportation: rail, ferry, and bus. The rail bar is the highest, which means that when rail accidents happen, they tend to cause more deaths. Because the ferry and bus bars are lower, that shows that on average their accidents are less deadly. Now that we know rail accidents have the highest average deaths, we need to look at what makes them more dangerous than other incidents. This chart shows how deadly accidents in different lighting conditions are on average. It highlights lighting conditions including artificial lighting, darkness, twilight, and daylight. The bar for other is highest, closely followed by artificial lighting and indoor lighting. This means accidents that occur in those lighting conditions have the average highest deaths. Research published in 2022 found that higher levels of light do not always make transportation conditions safer. Lighting and artificial lighting can create shadows and glares that make it harder to see. Visibility is vital to transportation safety, but lighting is not the only thing that affects visibility. This chart shows different rail crossing controls and the average fatalities per incident at each one. It includes active controls such as crossing gates, train approaching signs, quad gates, and flashing lights, as well as passive controls such as crossbucks and stop signs. The chart shows that the highest average incident deaths occur when rail crossing controls are active. This seems unexpected, but research published in 2024 provides some background into the issue. Researchers found that visibility problems can greatly impact railroad crossing safety even when crossing controls are active. Plants, buildings, and sharp turns can block driver visibility near railroad crossings. If drivers have limited visibility, it can affect their ability to react quickly to an approaching train. Now we've seen that visibility strongly impacts transportation incident fatalities, but design also plays a large role. This next chart looks at rail alignment and the average fatalities per incident on different kinds of tracks. When we look at rail alignment, it helps us get a deeper look at the impact of railroad design. The tallest bars on this chart are exclusive right-of-way tracks, specifically elevated tracks and tunnels, meaning they have the highest average fatalities per incident. This doesn't mean that accidents occur more frequently on these kinds of tracks, but it shows that when accidents do happen, they are more severe. This is very likely connected to visibility and reaction time. When examining Department of Transportation data, the combination of visibility and reaction time seem closely connected to the average fatalities per incident. While understanding where deadly accidents occur is important, it is only part of the story. It is helpful to look at what is going on in the moment the accident occurs to see the full picture. This next chart shows what transit vehicle actions were happening during accidents that caused the average highest deaths. The bar is highest for making a stop, which shows those accidents were most deadly. Research published in the Journal of Transportation Engineering found that human error is a major contributing factor in most transportation incidents. Making a stop could be more deadly due to human factors we have discussed, such as visibility and reaction time. Even if a problem is identified, it can be hard for trains to stop quickly due to their size. Now that we understand when, why, and where deadly accidents occur, we can take a step back and look at the bigger picture. This final chart compares different modes of transportation and shows both the total fatalities and average number of fatalities per incident. It shows that even though some types of transportation, such as buses, have a higher number of incidents, rail incidents have higher average fatalities. This means that even though rail accidents are less likely to occur, when they do, they are more severe. It is interesting to compare these two sets of data because they show that frequency and severity are not the same thing. As we have seen in previous charts, deadly accidents are influenced by visibility, design, and human behavior such as reaction time. The most dangerous transit situations are not where accidents occur most frequently, but where they have the deadliest impact on average. Improving transit safety isn't about avoiding travel, and it isn't even about reducing accidents overall. Accidents will always happen because of human error. Improving transit safety is about addressing specific situations where serious accidents are more likely to occur. To make transportation safer, it is important to understand and limit factors and environments that contribute to deadly accidents. Researchers suggest that drivers should be trained regularly about transportation safety and suggest that transportation engineers use new technology to increase overall safety. Implementing new technology has the potential to solve transportation issues that were difficult to solve in the past. In the end, understanding when, where, and why deadly accidents occur is the first step towards preventing them.